Minerals are composed of atoms arranged in ordered patterns. We can't see how the atoms are arranged by looking at a mineral sample, but the way the atoms are arranged affects the way a mineral breaks. In this video, you'll observe how minerals break and note the presence of cleavage and fracture in unknown mineral samples. After you watch this video, you can use your observations to help identify the minerals in your lab. We created this video because when you break a mineral, you ruin the sample, and because there are some safety concerns associated with breaking minerals. The fragments of the broken mineral may break off with a lot of force, and the particles from very small minerals are unsafe to breathe. So don't try this at home. The person breaking the minerals in this video is wearing safety glasses and a dust mask. Before we start breaking minerals, let's review cleavage and fracture. The atoms in some minerals are lined up so they break along smooth planes when a force is applied. This way of breaking is called cleavage because cleave is another word for split or cut. A mineral often splits in more than one direction. For example, this mineral has 3 directions of cleavage because you can see the planes pointing in 3 non-parallel directions. Minerals that don't split along smooth surfaces do not have cleavage. These minerals just show fracture. Some minerals, like quartz, have a distinct fracture formed from the shock wave where the mineral was hit. This kind of fracture is called conchoidal, and it looks like broken glass or broken ice. Because conchoidal fracture only occurs in minerals without any preferred zones of weakness, it is useful to identify minerals. Make sure you note conchoidal fracture when you observe it. Get ready to make some observations. Note the sample number of each mineral. Then, after each mineral is broken, make a note if you observe cleavage or just fracture. If you see cleavage, note if you see more than one direction in a broken piece. And if you observe fracture, you should note conchoidal fracture when you recognize it. Look closely at the sample. Do you see flat planes of cleavage in one or more direction, or do you just see fracture? Note your observations. We don't need to hit this mineral to see how it breaks. Notice how it splits into sheets. Sample 7 does not exhibit cleavage. It shows fracture. It breaks into semicircular smooth fragments along the zone of impact where it was hit. This is conchoidal fracture. Here's sample 13. Look at the broken pieces. It's easy to see that there are some flat sides. This mineral has cleavage, but let's see if we can say something about the number of directions. This mineral has 3 directions of cleavage. Sample 23 splits into smooth sheets along one very well-defined pane of cleavage. There are other flat areas that can be seen in this mineral, but the mineral doesn't break in that direction, so those flat edges are not examples of cleavage. Sample 25 does not break along smooth planes. It only exhibits fracture and crumbles like cement or chalk. Sample 26 breaks along smooth faces. It has 3 directions of cleavage at right angles to each other. Sample 27 does not exhibit cleavage. It seems to crumble in places, but also shows conchoidal fracture. Now that you've observed and recorded the presence of cleavage and fracture, you can use these properties to help you identify the minerals in your lab.